Hello, this is Mrs. Taylor, and I'm going to show you how to apply the exponent rules to simplified products. And I have three examples here. All are products because all are being multiplied. If you have parentheses and nothing between the sets of parentheses, that means multiplication. And you have to remember your order of operations with these. Remember parentheses, then exponents. Well, if you look inside of the parentheses, there's really nothing you can do to simplify using the exponent rules. And so you must go to exponents next before you multiply. And so in this first example, I have this exponent here outside of the parentheses that I must apply to what's in the parentheses before I can take this expression and multiply it by the other two. So that's something to keep in mind with all three of these examples. In this first example, I have 5xy all to the 0 power times 2x squared y times 4xy to the 4th. And what this situation would be is multiplying like bases, because I have an x and an x and an x, a y, a y, a y. So the rule is when you multiply like bases, you add the exponents. But keep in mind what I said before, with if you had exponents outside the parentheses, you must evaluate or apply that exponent first. And so in this case, I have 5xy all to the 0 power, and the rule is that if I raise anything to the 0 power, it just equals 1. And so I'm going to mark this first expression out, because 1 times anything equals the same thing. So if I multiplied these by 1, I'd get the same thing, so I can just basically ignore the fact that that's 1 at this point. So now what I do is I apply the multiplying like bases rule, where I take my like bases, like the x squared and the x, and I add their exponents. And so this x here that doesn't have an exponent, we understand it to have exponent of 1. And so x squared times x would become x cubed. And then y times y to the 4th would become y to the 5th. Now 2 and 4, they're just coefficients. They don't have, well, they do have exponents. They have exponents of 1, but they aren't like bases, and then it's 2 and 4. And so I would just multiply those coefficients. There's no exponents to work with. They're not like bases. I just multiply them. And so my resulting simplified expression would be 8x cubed y to the 5th. Alright, in this next example, I have a power to a power. I don't have any additional products to multiply out, so I just simply apply the rule that if you're raising a power to a power, you multiply the exponent. These you have to be really careful with, though, because they have a coefficient, and so you have to remember that even though you're multiplying the exponents, you're not multiplying this exponent times negative 4, you're multiplying this exponent times the exponent of negative 4, which technically is 1. And so the result of applying the exponent to this negative 4 would make it negative 4 to the 5th power, not negative 4 times 5. Another really important detail is when you're working with negatives and exponents, if the negative is in parentheses here, then when I apply this exponent of 5, I have to keep that negative 4 in parentheses, because it's negative 4 times negative 4 5 times. And if you don't maintain that set of parentheses, when you put it in your calculator won't think of it as negative 4 times negative 4 times negative 4 times negative 4 times negative 4. It'll just do 4 times itself 5 times, and then multiply it by negative 1. So all that being said, when I first apply this exponent of 5 to each of these items in the parentheses, initially it would look like this. I would have my negative 4 to the 5th, but make sure I have my negative 4 in parentheses. And then n would be raised to the 2 times 5 or 5th power. Same thing for n. And so if I simplify that further, I would compute negative 4 to the 5th in my calculator, and then go ahead and multiply the 2 times 5 for the m and the n. And so after I raise -4 to the 5th power, simplify those exponents, this will be my resulting simplified expression. -1024 times n to the 10th times n to the 10th. Alright, and then down here we have what looks like a monster of a expression to simplify, but if we just work a little bit at a time, it won't be so intimidating. So if I start with a 7 times j to the times k, or excuse me, 7 times j times k, there's no exponent outside of these parentheses, so I can just let this sit for a minute while I'm working on these other two. This middle expression here, I am raising -j cubed times k to the 5th, all of the second power. So this is power to a power, so it's similar to this example I just finished. And the thing to keep in mind here is if there's a negative out front, that's the same thing as saying -1 times. So I'm going to do the same thing I did with the -4 here, and I'm going to put the -1 in parentheses and raise it to the second power. And then I would just do 3 times 2 and 5 times 2. And then here I have a similar situation, except now my exponent is negative. So I'm still going to write it out as just 4 to the -1, but keep in mind that really that's the same thing as 1 over 4. And so just my first step in rewriting this would look like this. So I would have my 7 times j times k remain the same. I take this exponent of 2 and apply it to each of these items. So it would be -1 squared, and then the exponents of the j and k would be multiplied, so to the 6th and to the 10th. Same thing with this third product here, 4 to the -1, and then the 3 and 4, when multiplied by -1, would become -3 and -4. So now what I'm going to do is I'm going to group my like bases, my j's and my k's, by using the multiplying like bases rule, where I add the exponents. And then I'm just going to rewrite my 7 and my -1 squared and my 4 to the -1 all together at the front. And so I've written my 7, my -1 squared, my 4 to the -1 all up front here. And then when I add the exponents of the j's, that'd be 1 plus 6, which is 7, plus -3, which is 4. And then the k's, 1 plus 10 is 11, 10 plus -4 is 7, or excuse me, 11 plus -4 is 7. And so now all I have to do, because I have no repeat bases, is work with the 7, the -1 squared, and the 4 to the -1. Well, -1 squared means -1 times -1, which is +1. So 7 times +1 is just 7. And then this is 4 to the -1, which I mentioned early would be equivalent to 1 over 4, because remember, when the exponent's negative, cross the line, change the sign, this would be rewritten as 1/4 to make the exponent positive. And so 7 times 1/4 is 7/4. And so your final simplified expression would be 7/4 times j to the 4th times k to the 7th. And so that's how you would simplify these products. Some of them take a little extra time, but once you practice enough, then they move pretty quickly. You can kind of foresee some things in advance and do multiple steps at once.